Welcome to the Oscar II installation training video for the state of Idaho. What we'll cover in this presentation is what the technology is, how the Oscar II is installed, then once it's installed and electrical is hooked up, how to do the quality control or starter procedures, and then we'll go through the certification process so that you know how to get it on our list to install the technology. The Oscar II is a very simple process. It has four main components: a 1,000-gallon single compartment septic tank, 1,000-gallon pump chamber, and an Oscar drain field. The Oscar term stands for, or is an acronym that stands for, an on-site sand coil area recharge, and it describes what the technology is and kind of how it functions. Here we see an illustration of a unit that's been installed, but we're waiting for the final cover material to be put over the top of the coils. The technology is a treatment and a final disposal component all in one. We get a CBOD and TSS treatment levels of 2 and 3, so a very clean effluent. The components of an Oscar system are the drip coils, which each coil could be either a 50-gallon a day design flow or a 100-gallon a day design flow, depending upon what's on the design and what it's called for. The other component is the sand media, a minimum of 12 inches of sand underneath the coil. We do have a reverse flush headworks, and then of course we've got a couple of tanks that are involved. The OS50 coil, or the 5-foot diameter coil, it needs some field assembly, but it's a 25-foot length of bioline, Netafim bioline. We have emitter spacings at every 6 inches, and we use the 0.42 gallon an hour emitter. Again, there's some field assembly that's required. The green is just a background, and this 1-inch pipe, we call it a bracket, is just used to keep the coil in its shape during installation. The side view of the Oscar, you'll see that we've got a basal area where the soil surface has been prepared. We'll have some illustrations of how that's done here a little later. We'll place a minimum of 12 inches of sand under the coils. Out beyond the coil area, we only need to have 6 inches. And then on top of the coil, we'll have another 6 inches of sand. And again, this is all medium sand. Once the system's been installed and in operation for a season or two, we have nothing but a green grass growth that will grow over the top. This is a subsurface irrigated technology, so it lends itself very well to be put in a lawn area or a landscaped area. Now, the installation process of an Oscar, there's 6 total, and we'll go through each one of these. First of all, is we want to stake out the basal area. Most of the time, it's just going to be a rectangular shape, so we're going to have stakes in the 4 corners. Once in a while, we're going to have an Oscar that's shaped along a contour, so it may have a curved shape to it. So what we want to do is make sure that we're following along the contour. So we may have to do 2 or 3 or 4 stakes along the top edge to make sure that we're staying again along contour. Once we've got the area staked out, we want to remove any loose organic material. And what I mean by this is we don't want to remove the sod, but if it's in a pasture or a lawn area where we've got tall grass or weeds, we do want to mow that down to the surface. If we're in a forested area, we may want to take off the leaf duff and just enough to get down to the receiving soil or mineral soil. But we're not wanting to remove the sod itself. The preparation for the basal area is very simple. We just use whatever bucket, whatever machinery you have. We just want to put the teeth in the ground about 2, maybe 3 inches at the most. And we're going to just what I call rake or make one pass along the contour. And whatever material comes off, comes off. Whatever stays in the ground, stays in the ground. So you can see here we've got some sod that's remaining. a lot of sod that actually has been removed, and we'll I'll move this off and cast it off um, out of the way. Sometimes the site has really dry soil, and it looks like we're really not doing much, but just kind of mixing up the soil. But in effect, we really are creating a structure within the soil that gives us an ability to slow the flow of water down laterally. You can see here where we've got a lot of loose material, but we actually do have a groove and a hump. And so as water moves down through the sand into the receiving soil, if we're on a sloping site, we now have a structure under this basal area that will actually create more of the soil that's opened up, soil pores are opened up, but it also again slows the flow down as it moves laterally, so that we maintain a maximum amount of capability of allowing that liquid to infiltrate into the soil. Once we have the basal area prepped, we'll place our medium sand. Once the sand is on, we can drive on it with tractor equipment without too much trouble. Again, rake it out relatively smooth. Again, the 12 inches that we need to have is the 12 inches under the coils. The rest of it we only need to have 6 inches deep, so you can save yourself a lot of sand and cost by efficiently using the sand in the right places. Once the sand has been leveled out, we're going to place the coils and connect them. In the Oscar kit, these fittings, PVC fittings with the adapters, are already in place for you. We provide the blank tubing and then also the couplings that will put the blank tubing and the connected drip tubing together. And it's very simple, just putting the tubing onto the barb fittings. And the trick here is to lay the coils out. We do want to have a minimum of 6 inch spacing between each of the coils. And then the long pipes along the edge here, these are our manifolds. There's going to be a supply manifold and a flush manifold. The easiest thing to do is just to glue several lengths of 1 inch pipe together, and then just cut in the T's and the fittings. You can see here's a T. Just cut in the fittings where you want them, and then do your connections as per the design. In some cases, this case we have a curved site, and so they chose to put the manifolds on both sides of the line of coils, and this is completely legitimate. You'll just have to be careful when you're putting the tubing over the top that that gets bedded correctly, so it doesn't get a pipe doesn't get kinked. The tubing doesn't get kinked going over the top of the pipe. Now the required cover material over the coils is medium sand. It's the only thing that's required. You may want to put some soil over the top. If so, we only want a thin layer of 2 or 3 inches, and we want a very low organic soil. We don't want to put a lot of mulch or compost material that tends to absorb liquid and hold it, and it looks like our system is getting wet or soggy on top, that we may have some troubles when all it is just organic material holding liquid. Do recommend planting, if we're not able to plant right away, put some straw or something else to kind of hold the sand in place, but get some grass seed or ground covered planted, get it planted as soon as we possibly can. If you're concerned and you want to put some jute mat, that's just fine. But again, we want to avoid putting the pre-made topsoil mixes that are, again, real heavy in inorganic materials. We want to avoid doing that as much as possible. And when we're through with the cover sand, the unit will look pretty stark, um, not very attractive, but this will grow grass and other plants very easily once it's been put into operation. Total time to install an Oscar drain field is about 2 hours, a little less than 2 hours. Once you get the little tricks in place, two guys could do this easily in 2 hours. Of course, if you've got a site that has difficulty in being able to get material in near the Oscar basal area, It may take a little longer, but most installations is going to be fairly simple and quick. The placement of the reverse flush headworks will go directly on top of the pump chamber. It will be plumbed in as so. We do want to point the two coil from coil lines as directly as we can to the Oscars. We'll come out of our pump chamber at 90-degree angles to the headworks, and we will have a flush line, or what we call a vent line, which will go to a 4x1T supplied within the Oscar kit.
Now to talk about when cold weather happens. Because we have so much pipe and tubing that's well within the frost line when those cold months come around, when winter comes around, the main philosophy, if you will, on how to handle any cold weather freezing concerns that may be when it comes to Oscar systems is that if the water isn't there, it can't freeze. Namely, the idea is, and part of the design and the install, is that there's going to be slope and draining back into the tanks from the coils and all that tubing and piping out there, so that when the pump isn't on, the water isn't just sitting charged in pipes, where certainly during the colder months, if it's just sitting there, it'll freeze, but that water is going to be constantly moving, whether it's pressurized going out of the tubing or when it's not pressurized, draining back into the tanks. So that being a part of the installation is the key. If that's happening, freezing won't happen. Again, that's just physics. If the water's not there, it can't freeze. Other things to keep in mind, and another reason why we have a big point of emphasis on this for installation, the headworks itself is going to be needed to be located directly on top of the discharge tank. There's some natural thermal protection that happens for that piping in that headworks if it's on top of the tank. Excuse me, and it also has other practical uses by everything being close together, whether it's the controls or what have you, but the headworks being on top of the discharge tank, and that guarantees that the water and the elevation difference that's there can drain from the headworks back into the tank. And there's some insulation in our headworks boxes. By all means, you can throw some more insulation in that headworks box to help prevent the ill effects of the cold weather going on. So those three things, top one being the largest one, having that slope back from the drain field to go back into the tank, that is the numero uno most important thing to prevent freezing going on. Drain back. If the water's not there, it can't freeze. So here you can see the Oscar coils, this purple tubing, and they're exposed. So this is the point in the installation where the only thing left to do in terms of minimal cover is an additional 6 inches of sand on top of where the coils are. But the reason I show this picture is because you can see here in this bottom left corner of the image, you can see this 1-inch pipe here that's ultimately either going to be the supply or flush line supplying or flushing the water from this tubing. You can see it that it's exposed here, but as we go further down the bed or the length of this Oscar here, you can see it goes under the sand, and that's because there's a slope going on with this. So this next slide here, you can see if you were to look at this Oscar from a side view, the coils represented by these red lines here, they're all going to be on the same level and even plane, but this black line here representing that flush line or that supply line, that's going to be at a slope and sloping down towards ultimately where the headworks is going and where the tanks are. Again, another way that the key here is that this water that's going to be in this pipe is going to drain in between each doses. You'll have water that will continue to come out of the emitters if there's any water still remaining in these emitters out in the drain field, but then these lines here often will just stay level with these coils upon installation. So it's important to remember when we're talking about cold weather and frost prevention that we do have a slope here even within the Oscar drain field where the supply and flush lines on either side, where these manifolds are on either side of the coils, have a slope back so that water is able to drain. So just to harp on this point a little more about the importance of things being able to drain back, the idea of the placement of these drawings of the tank and the Oscar headworks is to show that there's an elevation difference here. So in the instance where if you were theoretically to have the tanks above where the Oscar is, the issue there when it comes to frost prevention and cold weather concerns is that even if you have these pipes sloped within the Oscar like we talked about, water can't drain back uphill. Gravity is still a thing, and you always end up having some sort of belly. Even in the instance where this is lower, it's important to remember that that slope or that kind of grade needs to be consistent back because any bellies will cause water to sit there, and in cold weather, that water can and ultimately will freeze. So this instance where tanks are higher in elevation than the Oscar, that does not work. Do not do this. This is not this will not work. In this instance, here you can see the arrangement of the drawings. We have the tanks at a lower elevation than the Oscar drain field. This will work appropriately. In this instance, you have that slope back down so that ultimately this line that's going back to your headworks, again, located directly on top of the tank, that will be able to drain back ultimately in two spots, one via this pump line back through the pump, as well as through this flush line here that's connected to a T that's back at the inlet of the entire system, back at the inlet for septic tank. We've all had those sites where, due to site conditions being really difficult to get your machinery out there, the idea of getting two tanks in a certain spot, again, keep in mind that Oscars are normally going on sites where space is limited. And so sometimes having the need to get both tanks at a lower elevation than the Oscar can be tough. But knowing that needing drain back and not having drain back is a non-starter for these when it comes to cold weather, know that you have the option just to have your discharge or pump tank below. So below lower in elevation than the Oscar. So bear with me. In this instance, if you were just to have your septic tank up near the house or wherever raw sewage is being collected, so long as you still have your both tanks being connected, you can just have your pump tank lower in elevation than the Oscar, and then you still accomplish that drain back that we're looking for. The thing to keep in mind with this is that that T that we discussed about, one of the places where that drain back water will go, we would just take that T that would normally be at the inlet of the septic tank here and put it in at the inlet of the pump tank, so that way everything is still able to flow downhill.
Inside the headworks, the internal portion is complete. You will have to glue at four positions: the from coil, two tank, and two coil, and the last one will be from pump. Once those are glued in, the plumbing to the headworks is done. You may want to adjust the box so that the guts to the headworks is centered within the box, so that these valves, none of the valves or anything you need to service, um, will be touching the side of the box. The external portion of the unit will just have these labels that will tell you where the plumbing's to go. Again, to and from coil are going to be connected to the manifolds of the Oscar, and two tank will go back to that 4x2T illustrated earlier. On the flip side of the box, you'll just see a from pump, and that's going to be the pump line coming from the pump chamber. Most of your installations are going to require a deeper barrier depth than the 1 foot that's 1 foot tall that the riser box will allow. In that case, we always provide a riser extension. The bottom of the box will be removed. The extension will just be placed on top of the headworks box. There'll be about 8 to 10 self-tapping stainless screws. You'll just screw the flange to the extension onto the lip of the headworks box, and that will be firm enough for backfill. Place the lid on and backfill, and you'll be done. The headworks boxes and the extensions work such that if you have a full 2 foot riser on your tank, by putting the riser extension, full extension riser on your headworks box and the lid, you'll come out at about 25.5 to 26-inch tall headworks arrangement. And if you were to compare that with the riser with your lid on there, the lids will be completely even, so it makes it real easy for backfill. Sometimes you'll want to have a riser extension less than a full foot. For instance, if you have an 18-inch tall riser on your tanks, you may want to then measure down from the top of the riser extension down your 6 inches, make a horizontal cut, and then remove the corner on all four corners. Also remove the flange on the bottom, and then screw with the screws that are provided, 2 or 3 on each side, just to hold it in place. The extension riser will not settle down with any kind of weight on top, the corners line up so that any of the weight that you may have on top of this extension will be just transferred down through the corner, then down to the bottom of the tank or bottom of the box. And when you're through, it's a little clean installation. And at the end, just put your original lid on the riser extension and backfill. Once the system has been installed and wired, we want to go through the process of doing a startup. We call a startup, it's just a quality control check. And this is to be done prior to final inspection before we call the health department out. And we're going to check to make sure the wiring for all the floats, pumps, and valves are done correctly. And we're also going to record some flows and pressures to be able to validate that the system is operating as intended. First thing we like to do is go through what the headworks is. It has several components. We use a 3/4 inch disc filter, which is about 120 mesh or 130 micron size of filtering mechanism. We have 5 normally closed solenoid valves, and we also incorporate 3 pressure gauges. Now, the solenoid valves, these are sewage valves. They are not irrigation valves put in the wrong application. These valves are all normally closed, which means in order for any water to move through them, they have to have hydraulic pressure at the valve as well as 24 volts AC to the solenoid. If we do not energize the solenoids, they will not open. Um, we do have the ability to manually open them, but we want to make sure that everything's working from an electronic standpoint. So it's important to know we have to energize the valves and energize the pump at the same time. Now the headworks layout, we've labeled the valves as solenoids or S1 through S5, and then the gauges are just labeled 1, 2, and 3, and then here's our disc filter. So we're going to go through the process of how we validate the correct wiring without actually knowing how to read a wiring diagram. Again, this is the system as it's completed, and so we're going to test hydraulically and electronically that everything's working appropriately. Now, during the normal function of the system, the control panel is set up to give us 90 dose cycles on and off, and these are preset. It's going to be 3 minutes and 30 seconds off and 22 seconds on. And we're going to go through 90 on-off cycles. Once we get to the 91st cycle, we're going to back flush the disc filter, and that's just a short 15-second back flush. We're going to reverse the flow through it and clean it off. Once that disc filter is clean, we're going to do a coil flush. We're going to clean the coils off, or the interior portion. We're going to flush them out. Once that cycle's done, we're going to go back to 90 more cycles, and then these 3 steps or cycles repeat themselves in perpetuity. The only time this stops is if there's not enough water in the tank. Our timer enable float goes down, and the system will just rest. Otherwise, we'll continue through these 3 cycles. So our control panel is set up so that we can electronically manually check these. We have 4 toggle switches. Top toggle switch is for the pump. We can do that in automatic off or turn it on manually. We have 5 solenoid valves. The valves solenoids 1 and 2 always work together, so they have 1 toggle switch. Valves 3 and 4 work together, so they have 1 toggle switch. And valve 5 is kind of an outlier. Valve 5 operates in conjunction with 1 and 2 to do the coil flush. We'll show you how that works here in a second. So if we want to do a check the valves to make sure that they're working properly, we are going to have hydraulic pressure. So we turn the pump on, and we have to also have 24 volts to the solenoids. So we'll turn these 2 toggle switches into hand or manual. And what that will do is turn the pump on, and this green line represents the flow of water from the pump. Solenoids 1 and 2 will open, which allows water to flow through the disc filter and will go out to the coil. The other three valves are shut, and so the only flow of water is going to go out the Oscar coils in the drip field. And what we're going to find is our pressures are going to be right around 50 psi with the standard single-family residence with the pumps that we supply in the package. That tells us that that portion of the system is working correctly. Again, without knowing how it's wired, we'll just do this functional test. So here's what it looks like. The pump turns on, water goes through the headworks, dosed out to the coils, and then we can actually see water dripping out the coils. If we run this long enough, what we'll see is if we've covered this with sand, the top of the sand will start to get moist. Now the next sequence is we're going to reverse the flow through the disc filter. The normal flow of the disc filter is water will come into the filter housing, go from the outside of the discs to the internal portion, and then from there go out to the coils. Well, we're going to reverse the flow, so we're going to, in a sense, pressurize the internal portion of this disc filter, forcing water at high rate through the discs, and then also separating them slightly. What's not shown here is a spring that's usually here in the housing that compresses these discs. By reversing the flow of water, we actually create some pressure where we compress that spring a little bit, and that releases these discs and gives it a little bit more space for debris to be removed quickly. We do that by turning the pump on again to get us hydraulic pressure, and we turn on this toggle switch to manual for valves 3 and 4. And now the yellow line indicates the flow of liquid from the pump. We're now, because our valves 3 and 4 are open, our flow of water now goes backwards to the disc filter, and then all that flush water then goes through what I call the vent line, and that will now go into the inlet of the pump chamber. What will happen here is our pressure on gauge 2 will be about 20 psi. Gauge 1 will be about 10, and we'll have 0 on 3. And then that gives us the indication that we've got, the valves wired correctly. Also, the amount of water that's flowing at this point will be about 28 gallons a minute, so the water coming into the inlet of that pump chamber will be at a fairly high rate. And this is what that flow would look like. The next step is we want to do a coil flush. So again, we'll turn on the pump to get hydraulic pressure. Because we want to get water to the coils, we need to turn on valves 1 and 2. And then we're going to relieve that pressure, so we want to turn on valve 5. And our flow, again, represents the green line. And it looks just like the dose, except we're going to now release all that excess pressure and flow through valve 5. And then again, that's going to go back into the inlet of the pump chamber. What we'll see here is our pressures on gauges 1 and 2 are going to drop down to about 40 psi. Gauge 3 will have, for the most part, 0. We might get 1 or 2 psi, but it'll be very, very low if it does register. Again, that's an indication that those valves are been wired in the correct place. And this is what the flow path will look like. The red or orange red lines represent the supply going to the coils, and then the orange line coming back into the tank through the vent line. Now we do want to measure the flow to make sure we have that we don't have a break or some malfunction in the coils. We use the RCal flow meters. We have kind of an odometer on the top to record over time what the amount of flow through the system is. But we also have 3 dials here that give us different flow rates. This dial will represent 1 gallon per digit. On this dial, each digit is 1/10 of a gallon, and on this dial, each digit is 1/hundredth of a gallon. So in other words, one rotation on this dial will be 10 gallons. One rotation on this dial will be 1 gallon a minute, or excuse me, 1 gallon per rotation. So if you're going to read this, the first black letter, or excuse me, number, it represents the 100 digit, so that would represent 200. The second one is tens, so that'd be 20. And the single digits represented by this painted zero, we have to read off this first dial. And of course, it's less than 1, so we have to then get the value off of the subsequent dials to be able to complete the reading of this meter. So if we were to record what the total flow is so far on this meter at this point, it would be 220.64 gallons. Now, let me back up one more. Now, the advantage of using this is, again, because each rotation on this is 1 gallon, when we want to measure the hydraulic flow, once we've pressurized the Oscar coils, all we need to do is count the number of rotations on this dial in 1 minute. And now we actually have what the emitter discharge rate or our GPM flow rate is. There's no math. We don't have to worry about adding or subtracting correctly or rounding correctly. Now, you do need to do a little bit of math in that the Oscar OS 50 coils on paper will flow at about 0.35 gallons a minute. So if you have 10 of those coils, your total discharge rate into the sand in this application would be 3.5 gallons a minute. If you were to use the OS 100 coils, they're twice as big as the OS 50s, and then they will flow at zero point 0.7 gallons a minute. So you will have to have an idea of how many coils, obviously, you put in place to be able to make sure that we've got the right flow rate. What we want to record, it's actually pretty simple. We want to record the gauge, the pressure on the three gauges 1, 2, and 3, while we're doing the dose. So that's with valve 1 and 2 open, and that's with the pump running. And then we also want to record the flow during the dose. Again, depending upon the number of coils, that will depend upon what our flow rate is. Now, a little bit about the certification process. It's kind of a 4 or 5 step process that we go through. The first one is you've pretty much just completed the classroom training or this online training. What you would do is then give me a call at this point, and we could go over any questions that you have, any details. We'll place your name on our certified professional list that we have posted on our website. And then when it's time to do your first install, somebody will come out. It may be a representative from our distributors or it may be someone from Low Ridge. Someone will be on the site for the first time. What we would expect to see when we got there was that the tanks would be in the ground, the basal prep would be done, and then the sand in place. Now, if you're not comfortable with doing the basal prep for the first time and would like to have someone there, then we'll go ahead and we'll do that for the first install. There's no reason for us to watch you put tanks in the ground. If you don't know how to do that at this point, we're probably not going to be able to help you out too much there. But so once we do the first install, then we'll have someone come back and do the startup procedures with you on site. And then if there's any additional training that you need, if we need to repeat this process again because it's been a long time between installs, or you just need a phone call and need some questions, we can also do things through FaceTime on iPhones or text pictures or videos of various things we're doing. So there's lots of different things we can do for additional infield training here and there, depending upon your needs. I hope you found this video informative, and we look forward to working with you in the future. Please feel free to give us a call when you need, and thank you for watching.